Assalamualaikum and hi, my name is Muhammad Islam Mustafa bin Abdullah from class RCS143-4E. Now I will explain about introduction to system of linear equation. A system of linear equations is a set of linear equations that we usually want to solve at the same time. There are many systems of linear equation. First is a linear equation with one unknown, ax equal to b. This equation have seen in form 1. Second is a system of two linear equations with two unknown. This system may have two variables such as x and y. This equation also have been solved in form 3. Third is a system of three linear equations with three unknown. This system may have three variables like in the equation below, which are x1, x2 and x3. Usually the variables will be replaced by x, y and z. This system also have been solved in form 4. Fourth, a system of m linear equations with n unknown. This system may have more than 3 equations and more than 3 variables. We have learned about the matrix and its operations, so now we want to use them to solve this system. Using matrix product, we can represent the system as matrices below. There are 3 matrices, matrix A, X and B. Matrix A is a coefficient matrix, matrix X is a variable matrix, and matrix B is a constant matrix. After that, an augmented matrix. Augmented matrix is created by joining the column of two matrices. Augmented matrix must have vertical line between two matrices like this matrix. Let's do some examples. Example 1. Consider the system of linear equations. This example have two equations. A. Write down the system of linear equation in matrix form. Okay, matrix form pass in a form of A as equal to B. So we need to do three matrices A, X and B. Matrix A is coefficient matrix, so we just fill the value of X in column 1 and value of Y in column 2. Matrix X, we just put the variable X and Y. Matrix B, we must put the constant value that have in the equation, which are 3 and 2. B. Write down the coefficient matrix A from the system. So we just take matrix A that have in example 1A. C. Write down the augmented matrix from the system. So we need to combine two matrices A and B with the vertical line between the matrix A and B. Example 2. Consider the system of linear equations. So this example have three equations. A. Write down the system of linear equation in matrix form. So this example will have three variables, that is x, y and z. So the matrix will be matrix 3 by 3. So matrix form is Ax equal to B. Matrix A is coefficient matrix, so we just fill the value of x in column 1 and value of y in column 2 and value of z in column 3. Matrix X, we just put the variable x, y and z. And for matrix B, we just fill the constant value, that is 10, 4 and negative 8. B. Write down the coefficient matrix A from the system. So we just take the matrix A just like in example 2A. C. Write down the augmented matrix from the system. So we need to combine two matrix A and B with the vertical line between the matrix A and B. Example 3. Consider the system of linear equations. So this example has 4 equations. A. Write down the system of linear equation in matrix form. So this example will have 4 variables, that is W, X, Y and Z. So the matrix will be matrix 4 by 4. So matrix form is Ax equal to B. Matrix A is coefficient matrix, so we just fill the value of W in column 1 and value of X in column 2 and value of Y in column 3 and value of X in column 4. Matrix X, we just put the variable W, X, Y and Z. And for matrix B, we just fill the constant value, that is 13, negative 1, 10 and 1. B. Write down the coefficient matrix A from the system. So we just take the matrix A just like in example 3A. C. Write down the augmented matrix from the system. So we need to combine two matrices A and B with the vertical line between the matrix A and B. System of linear equations Ax equal to b have two types, homogeneous and non-homogeneous system. For homogeneous system, value of b must equal to 0. For example, 2x minus y equal to 0 and 3x plus y equal to 0. For non-homogeneous system, value of b must not equal to 0. For example, 2x minus y equal to 0 and 3x plus y not equal to 0. So that is for me. Thank you.
Hi, my name is MAT263 CHAPTER and I'm going to explain about method to solve system of linear equations. In this subtopic, we have two methods, which is Gaussian elimination method and Gauss-Jordan elimination method. For Gaussian elimination method, first of all, we can reduce the augmented matrix representing a system of linear equation to a row echelon matrix using elementary row equations. Next, we change the row echelon matrix to a system of linear equation and solve this system using the back substitution methods. And for the Gauss-Jordan elimination methods, reduce the augmented matrix representing a system of linear equation to a reduced row echelons from matrix using elementary row operations. And let's solve the system represented by this matrix, but do not need to use back substitution method. Okay, now let's move to the example. For the Gaussian elimination method, solve this system of linear equations. X plus y equal to 3, for x minus y equal to 2. First of all, change the system into augmented matrix and solve it by elementary row operations. So first of all, row 2 plus negative for row 1, then row 2. Next, row 2 multiplied by negative 1 over 5, and we get this. Then, change the matrix into the system back. So we get x plus y equal to 3 and y equal to 2. By using back substitution method, we will get the solution y equal to 2 and x equal to 1. Okay, now for example of Gauss-Jordan elimination method. The first step is to write the augmented matrix of the system, as you can see below. Now our task is to reduce the matrix into the reduced row echelon form by performing the 3 elementary row operations. Okay, for step first, we can multiply the first row by negative 1 to make the leading entry 1. So step 2, we can now multiply the first row by 3 and subtract it from the second row, shown below. We have a 0 as the first entry of the second row. To make the second entry of the second row 1, we can multiply the second row by 1 over 2. Okay, we are almost there. So step 4, the second entry of the first row should be 0. In order to do that, we multiply the second row by 2 and add it to the first row. So this is the reduced row echelon form. From the augmented matrix, we can write two equations, which is x equal to 2 and y equal to negative 2. Next, in the subtopic, we have rank of a matrix. Rank of a matrix A is the number of non-zero rows from the row echelon matrix A, denoted as rank A. Now for the next part, we have a condition for the system of linear equations. System of linear equation Ax equal to b. Under that system, we have a homologous system. And under homologous system, we have a trivial solution, which is unique solution, and non-trivial solution, which is a many solutions. Next, we have a non-homogeneous system. Under that system, we have a consistent and inconsistent. For consistent have a solution and inconsistent have a no solutions. And under consistent, which is have a solution, we also have a unique solutions and infinitely many solutions. Okay, now time for the example. Consider the following system of linear equations. Now determine the value of A and B such that the system above has A, no solutions, B, a unique solutions, and C, infinitely many solutions. So now here are the solutions. First of all, we have to row 2 plus negative 2 row 1, and we get the row 2. Then we have row 3 plus negative 2 row 1, and we get the row 3. Next, row 2 multiplied by -1 and we get this. Lastly, we have row 3 plus 5 row 2 and we get the row 3 and we got the solutions. So the answer is for the A no solution, we have A equal to 22 and B not equal to -7. For B equation unit solution, we have A not equal to 22 and B is this. And for C many solution, we have A equal to 22 and B equal to -7. So that's all from me. Move to the next part.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Arsyad bin Muhammad Noh and my student ID is 2020X799. So for now, I will explain you about the inverse of matrix. Okay, so there is rule for subtopic inverse matrix. So the first is a non-square matrix is not invertible, and the second is only square matrices have an inverse. So the not square matrix don't have an inverse. Okay, so for the inverse method, we use a the power of -1 as a symbol for inverse matrix. Okay, and then for your information, the matrices will be identity matrix if multiplied with their inverse matrix. Okay, so there is two methods to find the inverse matrix. First is we using a formula, and the second is we using ERO, elimination row operation. So for example, by using formula, and this formula just will be used by 2 by 2 matrix only. So the formula for to find the A inverse is 1 over AD minus BC multiplied with matrix D, negative B, negative C, and A. Okay, so we go to the example. Okay, we have matrix A for and row. The first row is -1, 3, and the second row is -2, 5. So we must include the value of matrix A into the formula, and then we get the inverse matrix of A is the first row is 5, -3, and the second row is 2, -1. Okay, so we move to the next method, which is use ERO, elimination row operation. So in this method, to get the inverse matrix, the matrix must be augmented with identity matrix, and we will use Gauss-Jordan elimination to reduce the matrix A to be a reduced row echelon form. So here our example, our matrix it is A. So in row, the first row is 1, 2, -1, and second row is 2, 5, 1, and the third row is -1, -2, and 2. Okay, so the working is here. We move to the working. So this A after we use the row elimination method, and it will be identity matrix at the left side. So at the right side we get an inverse matrix, which is the first row is 12, -2, and 7, and the second row is -5, 1, -3, and the third row is 1, 0, 1. So that's all from me about the inverse matrix. So we move to the next subtopic. Okay, thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This is my turn, and now I would like to explain about elementary matrix, chapter 2, subtopic 2.4. So let's begin our discussions. Before that, let me introduce myself. My name is Muhammad Iskandar Minuzam. My matrix number is 2030864114, and I'm going to explain about elementary matrix. And about this subtopic, we're going to learn about first definition of elementary matrix. Second one is theorem representing elementary row operation. The third one, definition of row equivalence. And then lastly, theorem elementary matrices are invertible. So the first one is elementary matrix. The n matrix, which is square matrix, is called an elementary matrix if it can be obtained from the additive matrix In by a single elementary row operation. Next one is theorem representing elementary row operation. The second thing we're going to learn in this subtopic. We let E be the elementary matrix that obtained when we do an elementary row operation on Im. If the same operation is operated on an MXN matrix A after that one, the resulting matrix is given by the product A. Now we look at the three types of elementary matrices. The first one is row switching. If we create E by interchanging two rows, for example row I, we exchange with row J, then the inverse operation will take E and interchange the same rows again. Row J interchange with row I. The second one is row multiplications. We will create E by multiplying some row by a constant K is not equal to 0, K row A to row A. Then the inverse operation would be to take the E and multiply it by 1 over K row A to row A. And lastly, row addition. If you create E by adding a multiple of one row to another, for example row A plus K row B to row A, then the inverse operation will be to take E and subtract the multiple of that row off. For example row A minus K row B to row A. Next up, we're going to see about definition of row equivalence. Let A and B MXN matrix, which is not square matrix. Matrix B is a row equivalent to A denoted by B to A if there exists a finite number of elementary matrices E1, E2, and so on, such that B equals to EK, EK1, EK minus 1, E2, E1, A. Lastly, we're going to look at theorem elementary matrices are invertible. Each elementary matrix E is invertible, and the inverse matrix E negative prime 1 is also an elementary inverse is also an elementary matrix. So this is the elementary operation with its corresponding inverse operations are represented in the table below. Now we're going to the examples of this topic. Given matrix A 1 0 4 0 negative 4 0 0 0 1. The first is to find elementary matrices E1 and E2 such that E2 E1A is equal to I3. Find inverse of elementary matrices E1 E negative 1 negative prime 1 and E negative prime negative prime 2. The second is find inverse of elementary matrices inverse E inverse 1 and E inverse 2. And third one is write A as a product of elementary matrices. And this is the solutions for question 1. We got matrix 1 0 4 0 negative 4 0 0 0 1. We take row 2 and divide it with negative 4. So we got 1 0 4 0 1 0 0 0 1, and we take row 1. E minus 4 multiplied by row 3, and it's going to become 0 1 0 1 0 0 0 1 0 0 0 1, and hence elementary matrix E1, and we have 1 0 0 0 0 1 0 0 0 1. We use the same operations. Row 2 we divide with negative 4, and it's going to be 1 0 0 0 negative 1 over 4 0 0 0 1. Is equal to E1. Next up, we go to elementary matrix E2. 1 0 0 0 1 0 0 0 1. Use the same matrix. And then we're going to take row 1 to minus 4 multiple row 3, and we're going to take the result to row 1. So it's going to be 1 0 negative 4 0 0 1 0 0 0 1 equals to E2. The second question, the solution is inverse of elementary matrices. So E inverse 1, which the matrix is 1 0 0 0 1 0 0 0 1. we're going to take the row 2 and multiply it with -4. So we're going to get 1, 0, 0, 0, -4, 0, 0, 0, 1. Next up, inverse of mathematics, E inverse 2. So we have with the same matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. We take R1, row 1 plus V4 multiple with row 3 and take it to row 1. So the result is 1, 0, 4, 0, 1, 0, 0, 0, 1. And last question, the solution 3, we got E2, E1A equals to I3, E inverse 1, E inverse 2, E2, E1A is equal to E inverse 1, E inverse 2A. So we're going to cut E inverse 2. So we're going to be E inverse 1, E2, E1A is equal to E inverse 1, E inverse 2, and I3. So we're going to next up, we're going to do 1A is equal to E inverse 1, E inverse 2, and I3. So A is equal to E inverse 1, E inverse 2, and I3. So this is the solution. E inverse 1, E inverse 2, and I3 is equal to I0, 0, 0, -4, 0, 1, 0, 1. 1 multiplied with 1, 0, 4, 0, 1, 0, 0, 0, 1. And lastly, for I3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. So the result, the final result is 1, 0, 4, negative 0, -4, 0, 0, 0, 1. So that's the answer for the questions of the example that we discussed right now. I think that's all from me and all of us. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh, and thank you.